Welcome back to chemical technology. In the last module we have discussed the chemical industry and then we have discussed the unit processes and unit operations. So moving one step ahead, we will discuss BFD, PFD and P&ID for chemical processes. As you know, a picture is worth than 1,000 words. So same way, the flow diagrams convey more meaning than the description. So we have to see what those flow diagrams are. So generally, they are the BFD, PFD and P&IDs in the chemical industry. So today we will discuss how to define the different streams in a process, then to describe the meaning of standard abbreviations and symbols used on process flow sheets, then how to write a description for a process flow sheet, as well as if a description is given, then how to draw the flow sheets. So both we will discuss that how to draw flow sheets, and if flow sheet is given, how to describe it. Then what are the symbols used in that processes, so that we will see today. So first we have to describe what is meant by the process. So process is some operation carried out to modify input to output based on physical or chemical changes. So we have discussed in last class the chemical changes means the chemical processes, and then we have to carry out the physical changes, that is unit operations. So unit process and the unit operation combines, and that will lead to the product formation. So in this one, the input, which are the feed or reactant, that are processed, and that gives the production output at the other side. So the thing which converts input into the output, so that is termed as the process. Then as we have discussed the last class, the role of the chemical engineer. So in this one, we will discuss shortly about the role of a chemical engineer. So a chemical engineer has to specify the equipments and the materials and their subsequent arrangement into process. They have to analyze the operation in order to alter the processing operation to achieve a desired result, and then both problems require analysis and design functions. So in short, a chemical engineer has to analyze the problem and to find out the solution. Also he has to give the specification of the equipment and materials. So the chemical engineer is a job that he has to optimize the process in order to have the more output or the desired output. So lastly we have seen it's nothing but the permutation and combination of unit processes and unit operations. So always a chemical engineer will try to achieve yield equal to conversion. So for that one he has to specify all the things and optimize the process conditions. So if we will discuss these things with a small example. Suppose there is a problem in an oil-fired boiler in an oil refinery. So what is the problem? So in oil-fired boiler, that is one of the unit operation, and it is used for heating. So suppose it has a problem, then what we have to do? So first we have to analyze the problem. So first we have to see what is the actual problem in oil-fired boiler. So suppose the problem comes to be that the combustion is not complete. So combustion is not complete, that means there may be some problem in the air supply. So when fuel is burning, if the air supply is inadequate, then burning process will not be so much, and the efficiency of the oil-fired boiler will go down. So suppose this is the problem with the air, then what we will do? So we will suggest the modification, means what is the actual air supply and how much air is supplying to that unit. So that we will discuss and that we will analyze. Then if we come to know the air is inadequate and you have to supply the more air, then what we will do? We will design for a new air blower. Means the some problem where the air supply is inadequate, then we have to go for the new design of the air blower. So that's how a chemical engineer will analyze the problem. So he has to describe the processes. So there are the ways of the describing process. So one is input-output diagram, which is the simplest form. The block flow diagrams, which we have already seen in chemical process calculation, CPC. And in the chemical technology, we will mainly deal with the process flow diagrams, PFD, and the later on the process and instrumentation diagram, that is P&IDs. So as far as the chemical technology modules are considered, you will mainly deal with the PFDs, and P&ID will come in later stages of your engineering. So we will discuss one by one in details. So block flow diagram. So what it will happen? It will have the block, the input material on the one side and the output at the other side. So here it is a group of connected blocks of process units. So you will see the numerous blocks, they are connected and they are connected by the lines. So lines with arrow connects blocks and represent process streams. Means arrow will indicate from where the flow is occurring, from which side the flow is occurring. Then the raw materials or the input that will enter from the left, like we have seen earlier. So raw material will enter from the left and the product that will go out from the right. So here the product exists on the right. So there are four kind of process unit: the mixer, reactor, splitter and separators. So mixer, what it will do? All the raw material it will mix and it will give the output. Whereas in a reactor, suppose raw chocolate chip and cookie dough is fed, then it will give the baked chocolate chip and the cookies. So mixer it will mix, whereas the reactor will react on the input and it will give the output product. So you can see here the input is shown by the arrows and the output is at the right side. So all this mix and it is given by the flow diagram, so block diagram where we have mentioned the mixer. The next operation being the splitter. So input and the splitter will split into two. So input is splitted into two components. So two output we can have. And in a separator, whatever input it is separated. The difference between splitter and separator, separator will separate the two components, whereas splitter it may split the one component or it is a mixture of the n components. So the classification of this process is, so it is an integrated series of operations through which materials or energy are converted from one form of another. So three kind of processes we have in chemical engineering. They are the batch process, continuous process, semi-batch or semi-continuous process. So what is a batch process? So if you take the example of batch process, the input in batch-wise manner, whereas output also we get as a batch-wise manner. So if you take the example of fine chemicals. So what happens in batch process? In a reactor, we will feed reactant at once and then process is carried out and the output we take at once. So here the input we feed at once, output we get at once. So that's why it is called as the batch process. Whereas continuous, the input will be continuous and the output will be continuous. Means the reactants to the reactor they are fed continuously, whereas the output product we are getting out continuously. So input continuous and output continuous and it's named as the continuous process. If you take the case of distillation, so in a distillation we are feeding the stream in a continuous manner and in distillation tower it is separated and we can get the product at a continuous manner. So in a petroleum industry we are feeding the raw petroleum in a continuous manner and we are withdrawing the petrol, kerosene, diesel, naphtha in a continuous manner. Whereas the semi-batch or the semi-continuous, in this one input will be batch wise and output will be in a continuous manner. If you take the example of fermentation, what happens in this one? So in fermentation or the alcohol production, we are feeding the yeast with the nutrients and they are reacting and they are fermenting the input raw materials and they are converted into the alcohols. So here what happening? When the nutrients are very less in quantity, so the bacteria will go in the decline phase. So not to have this one, we will feed the reactants or the nutrients by time to time, so that the yeast will be active all the time. And also as the yeast, they are continuously converting the raw material into the alcohol, we can withdraw the alcohol from the reactor. So here what is happening? We are feeding nutrients in a batch-wise manner, whereas the alcohol we are drawing in a continuous manner, and that's why it's named as the semi-continuous process. So if we take the example and we will discuss, then it will be very much clear what is my batch, continuous and the semi-batch process. So if we take the coffee maker, what happens in a coffee maker? If we take the milk and the coffee and the hot water, so what will happen? We are feeding all the reactants at once and then we are mixing and then we are taking the coffee out. So this becomes the batch process. In an oil refinery, what happens? The raw materials is fed continuously and the products are withdrawn continuously. So it becomes the continuous process. If we take the human kidney, then what happens? Kidney is fed with the blood which contains the waste materials. So kidney has to work continuously and it can withdraw the waste material and the toxic material from the blood and it will purify it. So kidney works in a continuous manner. Then alcohol production unit, as we have discussed, it will be in a semi-batch manner. And if we take the human body, so human body, when it's active or when we are sleeping, the energy production is continuous one, because energy required to active the brain, to pump the blood from the heart and other body functions. So energy production is continuously, but for that energy production, we are not feeding continuously. We have the specific time of our eating, like we have the breakfast, then lunch, then evening snack, and then dinner. So what we are doing, we are feeding human body in a batch-wise manner, but the energy production is in continuous. So this becomes the case of the semi-batch. So next thing we will discuss is the PFD, or the process flow diagram. So what we have in this one? So PFD, or process flow diagram, shows the basic without the inner working of equipment or the control schemes. So the difference between BFD and PFD is that BFD it was the simplest, but whereas PFD will use the PFD in much detail than the BFD, but it will not show the inner working of the equipment. Like if we take the pump, then it will not mention the inner working of the pump or the specification of the pump, but it will define that there is a pump that we have to use. Then the concept of the flow sheet is applicable to many industries in the process flow diagram. The essential elements are the different operations that make a process, the sequence in which this operation occur. So main thing is here that it will have the block diagram, but some unit operation mentioned over it. But while mentioning unit operation, the inner working is not mentioned in PFD. The block diagram is there, unit operations are there, like heat exchanger, then pumps, pipes, all will be there, but the specification will not be there. That will come in P&ID. So here it is more in a descriptive manner and can be applied in widely. So if we take the case of the PFD, we will discuss the case of home oil burner. So generally, a home oil burner is used to keep the home warm. So generally this is used in cold countries. So what happens? We are supplying the cool air from the house and we want to have the warm air in the house. So what we will have? We have to heat the cool air. And how to heat the cool air? So this is the burner where the oil and the air will be burned. So that will release the energy in terms of the heat energy, and that heat energy will heat the cool air and give you the warm air. Whereas the whatever the flue gases that we are sending to the chimney or outside. So how to make this as a process flow diagram? So much detail we will incorporate in this one. So what happens? Cool air, when we have to feed to the burner or heat exchanger unit, so what we have, we should have the fan or a blower. So what cool air, with the help of a fan or blower, we will feed to the heat exchanger unit, that is burner over here. Then oil, which is a feed to the heat exchanger unit, so that oil will not come its own. So we have to pump the oil and we have to pump it from a storage tank. So oil will be stored over here, and with the use of a pump, we will pump the oil into the heat exchanger units. Whereas here is the air which may take from the atmosphere, or we may have the another fan blower from this side. So it may be the from atmosphere or the from this. So what we have, the unit operation, the blower is one of the unit operation, pump one of the unit operation, so that we are using over here. Then it will be more complete that whatever the warm air which is going to the house, we can again recirculate over here. So what we have the energy efficient process flow over here. So you can see simple block flow diagram, with the use of unit operation, we are converted into the process flow diagrams. Then how to draw the PFD? So we will take a small example of synthesis of ammonia. So we will just read out what is given in the process. So mixture of hydrogen and nitrogen is fed to a catalytic reactor where some of the hydrogen and nitrogen is converted to ammonia. So it will tell what are the reactants. So reactants are hydrogen and nitrogen, and that is to convert it into the ammonia. The reactor effluent is sent to a condenser where all the ammonia is condensed. So the effluent is sent to the condenser where the all ammonia is condensed. So ammonia is condensed in the next step. The condensed ammonia is sent to the product storage. Final product is sent to the storage. The uncondensed hydrogen and nitrogen are recycled by being mixed with a fresh feed of the same composition. So whatever the nitrogen hydrogen that are unreacted, that has to be recycled in order to have the more conversion. But one thing we should take care that the fresh feed should have the same composition, and whatever the recycling, they will have the same composition as the fresh feed. And the last one is the resultant mixture is fed to the reactor. Whatever the recycled one is again fed to the reactor, and then again this will continue. The reactor will convert ammonia, then condense, and then go to the storage one. So now we will discuss how to draw the process flow diagram from the given description. So first thing we have to do is we have to analyze which type of process it is. So type of process. So here we can see reactor and condenser are continuous, because reactor is fed continuously with nitrogen and hydrogen, whereas condenser is continuously condensing the final product, that is ammonia. The storage tank is semi-continuous, because what happening in storage tank, we are intermittently storing the ammonia over it, so it becomes the semi-continuous one. So after knowing this process that this is the continuous one and this is semi-continuous one, the next thing is what are the chemical changes occurring. So chemical changes, we have the reaction, nitrogen 1 mole when reacted with 3 moles of hydrogen, we give the 2 moles of ammonia. So we will see this by process. So now the description, we will convert it into the process flow diagram. So first thing is given, a mixture of hydrogen and nitrogen is fed to the catalytic reactor where some of hydrogen and nitrogen is converted to ammonia. So we have the feed, we have the reactor, and then we will get the effluent. So feed here is nitrogen and hydrogen, and the effluent is ammonia, which is finished product with some unreacted nitrogen and hydrogen. The next thing is the reactor effluent is sent to a condenser where all of the ammonia is condensed. So the feed nitrogen hydrogen, which gives ammonia and unreacted H2H2. So the NH3, which is in liquid form, is stored in the storage tank. So reacted and whatever the effluent, they are condensed, and only NH3 is stored in the store tank. The next thing is the uncondensed hydrogen and nitrogen are recycled back by being mixed with a fresh feed of the same composition. So what we have to do? So N2NH2, which are unreacted, so what condenser will do? It will allow NH2 to condense, and N2NH2 it will send back to the feed. So what we have to take care that N2NH2 while mixing with the feed, it should not disturb the composition over here. So while mixing this one at this part, it should be the desired composition that will lead to the reaction. Like here, we should have the ammonia, nitrogen and hydrogen in specific proportion. So that should be maintained over here. So the recycle stream should not disturb this one. Then it will react, and whatever the unreacted, it will convert. So we are getting more conversion over here. So the recycle, so how much recycle should be there? So that we have already discussed in the CPC. So same way. So what we have, the feed, the reactor, the condenser and storage. So it looks like a block flow diagram. And the recycle and the purge to the atmosphere. The next one comes is the piping and instrumentation diagram. So what we have the plant construction informing like piping, process, instrumentation, and the other diagrams in this one. So P&ID, is a more advanced stage of PFD, and it will discuss in more detail about the control units and the specification. So PFD was not mentioning any specification, but in P&ID it will mention each and every detail. Then all the equipments are used, a complete instrumentation methodology is adopted, the size and type of the pipe, design and condition of the equipment. So P&ID, in other way we can say, is the diagram for the actual process. So P&ID will give the actual picture of the chemical industry, and it will have the all details of the instrument, equipments, pipe and their sizes, and the design requirements. So first we will see the instrumentation and the control. So instruments, they are used to sense, process variable and drive control valves, and these are denoted by P&ID by circles with letters. So suppose if you take this example, so you can see a circle is drawn over here and the letters we can see L and C. We will see what they mean by. Another if you take, it's a FRC. So two alphabets or maybe 3 alphabets. So we will discuss what they mean. The valves are connected by solid lines to the point where variables are measured and by dotted lines to the equipment they control. Suppose this is a valve and this is the instrumentation control like FRC. So what happening? So it is joined by the dotted line. So means the flow through this valve is controlled by this one. So what it will sense? It will sense what is the flow going towards the valve. And suppose the flow is not desired one, so it will indicate that flow through the valve is not of the desired level, so please change. So we can change by giving the feedback or we can change it manually. So generally nowadays it's automated, so this will take care of that the correct flow goes through the valve. So the purpose of this instrumentation and control is to monitor what is occurring at that level. So it may be the valve, it may be the reactor, it may be the heat exchanger unit, it will sense. So depend upon the unit, we will have the different control systems. So we will see which kind of the control systems we have. So they are denoted by the alphabets. So earlier we have seen LC. So L is the first alphabet, C is later on. So L represent level, that is liquid level. Then C came second. So C will represent the controller. So generally, so LC means level controller. Similarly, if we take the other example FRC, so what FRC? F is the first one. So first one it will indicate flow. Then R is the second one, that is recorder, and C is the third one, that is controller. So it is flow recorder controller. So level controller and flow recorder controller. So here what is does? It will measure the flow, it will record and it will control. So similarly there are different kind. A represents for analyzer when it comes first. Second it will be alarm and third it will be alarm. And similarly others are there. Then there are different kinds of the control systems. If you take the example TR, so that will represent temperature recorder. Then LI, it will indicate the level. So level indicator. So in a block or in a circle, it may be two alphabet or 3 alphabet, and some numbers will be given. So how to read them? So first it will denote the variable which is being measured. The third one it will denote what is does, and third one it will be instrument that are using. The numbers that will give the control loop, and the line which will represent the remote location or board mounted. So if you see at that point, without line it's a field mounted and with line it's a remote location, means it will appear behind the control panel. So if you take the case of FIC, so FIC means it will measure the flow and the I will represent for the indication. So what does the flow indicator and the controller? So it means it will control. So it will see the flow, it will indicate that it is changing and it will give feedback to the instrument. So here the first letter describes the variables sensed by the instrument. They are pressure, temperature, flow, level or liquid level or the composition. The second and third letter describe the action taken. So it may be recording, indicating, or alarming, or controlling. So you can see, now we have just explained the LC and FRC. So if we take the case of P&ID, so this is the simplest diagram for an FID. So here you can see, this is the simple distillation column. So what we have, this is the distillation column. Feed is coming to the distillation column. These are the bottoms which are controlled through these valves. Then the bottoms will contain the more high boiling liquid, whereas the top section will contain the vapors which are of the low boiling point. So this will separate the mixture depend upon their volatility. So you can have here the more volatile, here we can have the less volatile. Here it will be in a vapor form, and that we are condensing over here. So this is the condenser, and D1 is the storage when we are storing over there. So starting each and every component, so feed, and here is the controller, the valve. Then the feed is controlled by the PRC. So you can have the PRC mean by what? Then the top section, we have the condenser E1, and then it is storing in D1, and which is controlled by the LC, or their valve we have there over. So it will LC, so level controller it will have at the D1 side. Then at the reflux side, we have another valve, and it is connected to the instrument TIC. So here we have the controller, temperature indicator controller. Then E2, what it does, it will recirculate it. So it again the heat exchanger unit. And the valve, what is the withdrawal, is controlled by the level indicator. And same way, the ARC and flow control at the valve where we are taking out the all means bottoms. So we will see how to describe. So first thing we will see, so there are C1, E1, D1 and E2, these are the unit operation, where are PRC, LC, ARC, FC, they are the instrumentation which has to be controlled. So we will see how to describe this diagram. So first thing is, main pieces of equipments are column, that is C1, accumulator drum D1, reboiler E2 and condenser E1. The distillation column C1 separate the feed stream according to the volatility into overhead and the bottom products. The heat exchanger C1 and E2 condense the overhead vapors and partially vaporize the liquid from the bottom of the column. The drum D1 accumulates the condensed liquid and also accumulates surges in overhead product rate. Control elements are shown by the circle and dash lines. So as we seen earlier, C1 is the column, E1, E2 they are heat exchanger units, D1 is the storage drum, and from here we will have the feed. Then the flow, the control elements, they are in the circle. So we will see what are the control elements. So the rate of bottom's withdrawal is controlled by the liquid level in the bottom of the column. When the level rises, the valve is opened to increase the withdrawal rate and thus lower the level. So the bottoms is controlled by the level indicator. So when we see the level rises, the valve is opened to increase the withdrawal rate and thus lower the level. So what does it will do? So bottom withdrawal is controlled by the valve over there. The net bottom flow is controlled by an analyzer which sets the flow controller on this stream to the reboiler to maintain the bottom composition within the specified limits. The next one, the net overhead withdrawn from the drum on level control. When the level D1 rises, the valve is open and this keep level in the tank within the preset upper and lower limits. And the rate at which reflux is returned to the column is controlled by the temperature at a particular point in the column. When this temperature rises, the valve is open and more reflux flow to the column. This instrument is an indicator as well as the controller, so it sends a signal proportion to the temperature to read out instrument in the control room. The column feed is controlled by the FRC. So we will see what does it mean. So it is nothing but describing. So what does they have described the TIC control the reflux. The LC will determine the storage net overhead The ARC will describe the bottom and the what is the rate of withdrawal, and this will indicate the level at the bottoms, and here the PRC will indicate the feed it has to flow. So this will control the feed, control the reflex, that will control the net overhead, and this will control the level. So that is all mentioned in this one. So in the next module we will start with the industries. So in next module we will discuss about the sulfur and sulfuric acid.